Okay, good morning. Just to let you know, there was a mistake in the notes that I had printed. I put a new version on the um, to-do list that you can print out. But what I had done is I had screwed up the pictures, like these two things right here were in the wrong spot. So you just need to make sure you flip them. So this first set of information is for horizontal and it looks like this. And this second set of information is for vertical and it looks like this. Okay, so an ellipse. We're talking about if we were to cut the cone and instead of going straight horizontal, we're going to go on an angle. So it makes it so that like one part of the circle is longer than the other. So it makes an oval. Okay, an ellipse is a set of all points whose sum, or the sum of whose distances are distances from two distinct points. These 2 points are called your foci, are constant. So we have these 2 points that are inside the ellipse. Realize that your foci have to be inside the ellipse. Okay, where the distance from here to here and here to here, when you add it together, is going to be the same no matter what point you choose on the ellipse. So I could choose a point here, and the distance from here to here and the distance from here to here, when you add them together, is going to be the same as what you get when you add these. Okay, so couple vocab words. We have our center. Our center is our middle of our ellipse. Okay, that means it has to be in the middle between the co-vertices and the vertices. Okay, your vertices are the ends of the longer axis Your covertices are the ends of your shorter axis. Okay, now let's get a little more specific. Instead of saying longer axis, we're now going to call this our major. So our major axis is our longer axis. Okay, and then instead of calling this our shorter axis, we are going to call it our minor. So our shorter of our two axes are going to be our minor axis. Okay, so when we look at these, here's our information. Our standard form is x minus h squared all over a squared. So this should look familiar to you. A squared is going to be your denominator, plus, this is a key thing, okay, plus. So when I think of an ellipse and how I remember that the equation has to have a plus sign, is I think that the two parabolas have to come together. So it's like having two parabolas and then they come together. So when you put things together, you add them. That's how I will always remember it, because our next one is going to also look very similar to this, okay, except for there will be a minus there when we talk about what we call hyperbolas. Okay, plus y minus k squared all over b squared equals 1. Okay, your center is still at hk, just like before. Your vertices are h plus a and h minus a. Now realize this is a versus a squared, so you're going to have to square root this number to get what you add and subtract. Comma k. Your foci are h plus or minus c. Now you're like, okay, where does this c come from? The C comes from the idea that we are going to use it's very similar to the Pythagorean theorem. Okay, and for the ellipse, because you're going to get one of these for a hyperbola too. Your Pythagorean theorem that you use here is a squared equals c squared plus b squared. Okay, that is something that is not on your formula sheet. So you're going to have to remember this. So whether it's you make a note card with it so that you practice it every day, you write it on a piece of paper 10 times, ellipse, a squared equals c squared plus b squared. Okay, you have to have this memorized. It is not on your formula sheet. Okay, and then the ends of your minor axis are h comma k plus or minus b. Okay, when you change it to a vertical, your A, B, and C are still following the same thing. So your A is your vertice, your C is your foci, and your B is your minor axis, but realize you're adding it to the other part. So instead of adding it to the X value, you're adding it to the Y value. Okay, so now how do you tell whether it's a vertical or a horizontal? That is going to be your bigger number. Your A always has to be your bigger number. So A is always bigger than B. Okay, so if your bigger number is under the X, that's horizontal. If your bigger number is under the Y, that's vertical. Okay, if your bigger number is under the X, it's horizontal. If it's bigger number under the Y, it's vertical. Okay, so when we talk about major and minor, remember your major is your longer. So your major would be this. Okay, and then your minor axis would be this distance here. This is your minor axis. Okay. The other thing to remember here is that A and B are always only half of your major or minor. So this distance from here to here is A. So this isn't like plus or minus, even though I said that, sorry. It's plus and minus. So you're going to have to add A to get the left side, or sorry, add A to get the right side, and then subtract A to get the left side. The same thing with your minor. This is only B. So the whole distance is actually 2B long. Okay. In this case, this one is our A, and then this is our B. Okay. But remember, A and B are only half of the whole distance. Okay. So here we go. Our first thing we're going to graph. We have x squared over 16 plus y squared over 9 equals 1. Okay. So our h is 0. Our k is 0. Okay. Our h is 0. Our k is 0. Our a is always the bigger number, so our a would be the square root of 16, which is 4. And our b would be the square root of 9, which is 3. Okay, so my center is at 0, 0. So my 0, 0 point is there. Okay, my vertices. This is opening horizontal because the bigger number is under x squared. So this is a horizontal major. So for my vertices, I'm going to go 4 units to the left and 4 units to the right. So my vertices are going to be at 4, 0 and -4, 0. Okay, I go 4 units, 1, 2, 3, 4, and 4 units, 1, 2, 3, 4. So there are my vertices. My co-vertices, they should be closer to the center. My co-vertices are 3 units away from my center, but those move up and down, so make sure you change the correct number. So that's 0, 3 and 0, -3. So 1, 2, 3, 1, 2, 3. Okay, and there is my ellipse. It's very close to a circle in this case, but it's not a circle because it's not perfectly round. We don't go up the same as we go down. Okay, our foci. Our foci, that is where we're going to have to use this a squared equals c squared plus b squared part. Okay, because we don't know this c number to be able to figure out where my foci are. So my c is what I need to find. So I'm going to do a squared equals c squared plus b squared. The more I write it, the better I'll get at it. So 4 squared equals c squared plus 3 squared. So 16 equals c squared plus 9. Therefore, 16 minus 9 is 7. So we get 7 equals c squared. So c is equal to the square root of 7, which is about 2.65. Now, your foci have to be in the same parts as your vertices, not your co-vertices. So it's going to be changing my x values, and I'm going to go to 2.65, 0 and -2.65, 0. So my foci are going to be at 2.65, which is here, and negative 2.65 and positive 2.65. And there's my ellipse. Okay, my C is at 2.65. Okay, next one. First thing I noticed is the bigger number is under the Y. Bigger number under the Y means that it's going to be vertically longer than it is horizontally. Okay, so my H is at -1. My K is at +3. Don't forget to change their signs. My A is the square root of 25, which is 5. And my B is the square root of 9, which is 3. My C, I don't know yet. Okay, so my center is at -1, 3. Okay, so -1, +3, 1, 2, 3. Okay, my vertices. In this case, my vertices have to be up and down, so I'm going to be adding this A number to 3. So it would be -1, comma, 3 and 5 make 8, and -1, comma, 3 minus 5 is -2. So in other words, if you don't want to do the actual adding, you can just count. I go up 5, 1, 2, 3, 4, 5. There's one vertice. And I go down 5, 1, 2, 3, 4, 5. There's your second vertice. Okay, my co-vertices. My co-vertices move my x value now. So if I go 3 to the left, it would be -4, comma, 3. And if I go 3 to the right of -1, I'll be at +2, comma, 3. Okay, once again, if you don't want to do it, you could count. So I start at my center, I go 3 to the left, 1, 2, 3, which is at -4, comma, 3. That's right, I got. And 1, 2, 3, which is at +2. And then I can go ahead and connect my points to make my ellipse. Okay, be careful, make sure they're curves, not straight lines. Okay, my foci, those are the last ones I have to find, but I don't have my C value yet. So I'm going to do A squared equals C squared plus B squared. So my A is 5, 5 squared equals C squared plus 3 squared. So 25 equals C squared plus 9. C squared has to be equal to 16 then, therefore C has to be equal to 4. So that means I'm going to go up 4, down 4, okay, from my center. So that would make me be at -1, comma, 3 and 4 make 7. And -1, comma, 3 minus 4 is -1. And then I can go ahead and graph my foci. So 1, 2, 3, 4, there's a foci. And 1, 2, 3, 4, there's the other one. Okay, to convert to standard form, very similar to circles. So first thing I'm going to do is I'm going to rewrite. I'm going to rewrite so that all my x's are together and anything that's doesn't have an x or y on it is on the other side. So 4x squared plus 16x plus y squared minus 6y equals, to move the 39 to the other side and make it positive. Okay, so now I'm going to complete the square. So first thing I see is there's a GCF here. So I say 4 times x squared plus 4x plus blank plus y squared minus 6y plus blank equals 39 plus blank plus blank. Okay, remember these are two pluses because it's on the other side of the equal sign. So my two missing numbers, to make a perfect square, this would have to be 4. Don't forget this 4 and this 4 have to be put together to make a 16 over here. And this one would be 9, so this would be 9. Okay, so I get 4 times x plus 2 squared plus y minus 3 squared equals And then I can go ahead and calculate 39 plus 16 plus 9 is 64.